Hello everyone, thanks for joining. My name is Animesh and I'm part of IBM Cloud team. I've been working around the combination of Cloud Foundry and OpenStack over the last 1.5 years. And why do we care? Why do these two technologies should intersect? Well, in the end, we want to deploy lots and lots of applications. And as of a recent study done by CRISP Research, OpenStack and Cloud Foundry, in fact, are the top two open source cloud technologies. Now, what's Cloud Foundry? First of all, it's a very open platform as a service. It meets developers' needs. You can go to Cloud Foundry with your code. It's smart enough to detect what runtimes you need. And as you tell Cloud Foundry the services you want to provision, it will go ahead and provision in an automated fashion. And last but not the least, it has a very vibrant and strong community. More than 700,000 lines of code have been written, and around 1,300 developers across different companies like IBM, VMware, SAP, HP, etc. are contributing code to it. How is the user interaction? You can interact either through a CLI, through an Eclipse IDE, or through a browser. And as you push your application, Cloud Foundry gets it up and running, and in the end, you can actually access the URL through a browser. What's happening under the covers? As you push your application, it hits Cloud Controller, which is the heart and brain of Cloud Foundry. It then actually pushes it on top of VMs, which in the Cloud Foundry parlance are called DEA or droplet execution agents. Your applications are actually wrapped with a runtime and framework and deployed in Warden containers currently, which is being rewritten, in fact, to support Docker containers. And once it's up and running, the router has the URL and you can actually access it. And then there is a health manager, which is responsible for managing the lifecycle once the applications are up and running through a NATS messaging bus. Now, IBM Bluemix is an offering which is powered by Cloud Foundry. It's an IBM initiative to develop platform as a service, and there are a lot of services from IBM, from partners, etc. And it is also an integrated DevOps tooling with Eclipse and browser-based Orion tool. You can actually register at bluemix.net. Very, very rich catalog of services. And in fact, OpenStack Swift is also being offered as a service in Bluemix. So how do Cloud Foundry and OpenStack integrate together? Well, in this case, the integration is provided by BOSH, which is a lifecycle management tool for Cloud Foundry. It deploys Cloud Foundry on top of OpenStack, but a vanilla install of OpenStack is not sufficient. You need to customize OpenStack with static and floating IPs. There needs to be support for persistent disk. Custom VM flavors need to be created for different Cloud Foundry components like routers, Cloud Controller, Health Manager, etc. And definitely you need specialized security groups. So how does BOSH work? BOSH actually takes a release. A release is a compilation of packages. For example, MySQL is a release. A Node.js is a release. It compiles all those packages and deploys on stem cells, which are base OS images and converted into different Cloud Foundry components. At the heart of this deployment is a deployment manifest, which combines all this information on which network I need to deploy, what are the credentials to get into infrastructure as a service, in this case, OpenStack, what is the stem cell image I'm using, what are the releases which should be deployed. That's all compiled in the deployment manifest. And once it's there, BOSH actually takes the deployment manifest and converts it into a Cloud Foundry deployment. So as we saw, this deployment manifest can be complex, in some cases running into 1,000 lines. Also, you need specialized knowledge about OpenStack, about Cloud Foundry, about BOSH to be able to deploy Cloud Foundry on OpenStack. So let's see how we can leverage the power of open source community to actually go from a bare metal hardware to a running Cloud Foundry in a matter of an hour. Since both OpenStack and Cloud Foundry have a very strong open ecosystem, we can leverage tools like Chef to automate the installation and configuration of OpenStack itself to set up OpenStack controller, compute, network, storage. This can be done right now in 15 minutes. Once OpenStack is up and running, as I discussed, we need to collect a lot of information from OpenStack. What all information do we need to collect? Well, we need to discover security credentials, VM configuration sizes, What are the network subnets, network security rules, DSCP, DNS, etc.? How do we automate the discovery of this information rather than somebody going manually and entering it? We use a tool like Fog, which in fact BOSH under the cover uses. Fog is a cloud services library which actually allows you to talk to a variety of cloud providers. Now, we not only discover this information, we can also do a lot of Cloud Foundry Pre-req setup on OpenStack. As we discussed, a vanilla install of OpenStack is not sufficient. We need to customize it. So we can again leverage the same Fog gem to customize a lot of things on OpenStack for Cloud Foundry deployment. What all do we need to customize? For example, we do need to create some security credentials, create VM configs. There are recommended sizes for cloud DEAs, cloud controller, service nodes, etc. We need to create specialized network security rules. We need to check the tenant quota. All that, again, can be done leveraging the power of Fog. OK, so we have collected all the information. We have done the pre-req setup on OpenStack. Now it's the time to deploy. Now, before that, we do need to generate that manifest file. How can that be done? Well, in our case, we have automated it using Ruby ARB templating mechanism. So we take all the data which we have collected as part of the discovery and enter into this Ruby template in an automated fashion. And then we kick off BOSH to deploy Cloud Foundry in the background. So some of the steps it goes through, for example, being able to update and upload Cloud Foundry releases, service releases, then it deploys micro BOSH, and then we actually deploy the Cloud Foundry itself. So what we have seen is that by leveraging the power of open source technologies like Chef, BOSH, Fog, Ruby, we can actually go from a bare metal hardware to a running Cloud Foundry in under an hour. This underlines why open source is so important. Why do we need to have a strong ecosystem and community around open source technologies? OK, so we have deployed. How about the update and the upgrade operations? How can we automate that? So we can actually use the same workflow and the same technologies in the previous step. For example, if we want to update a Cloud Foundry deployment on top of OpenStack, we can again run a discovery so as to get a live state of the underlying OpenStack infrastructure so that we are sure that there are no IP addresses which are missing or the flavors, if there are configuration sizes which have changed. And once it's done, then we can, under the covers, use BOSH itself. Because as I mentioned, BOSH is a lifecycle management tool for Cloud Foundry. It's beyond deployment. What all we can update? Well, we can change the sizes of the different Cloud Foundry components like DEAs, cloud management, cloud controller, service gateway. We can increase the number of DEAs or application nodes. We can change the domain name, the floating IP. We can actually update the stem cell versions itself and the Cloud Foundry versions of itself. So all this can be done in an automated fashion, leveraging the same technologies I just talked about. Great. So what happens to the application when you are doing these automated updates and upgrades? Well, in the background, as you can see here, we actually used a tool called JMeter to test. The applications are always up and running. So BOSH uses a mechanism, rolling upgrade mechanism, actually, to make sure that as it's updating a Cloud Foundry deployment, there is no application downtime. So that means it defines a set of canaries, and once the operation is successful on that set of canaries, then actually it does the full-blown deployment. OK, so we have been able to automate the deployment of Cloud Foundry on OpenStack. We have been able to automate the update and upgrade. How do we scale this environment? So there are a couple of things which we found out as we were working through it, that we need to configure OpenStack for scaled concurrency. That means configuring the RabbitMQ queue, etc. And not only that, we also need to change the default scheduler at OpenStack because BOSH deploys a lot of VMs concurrently. So if you're pushing like 60 VMs, 30 VMs at once, OpenStack gets bottlenecked. So we need to change that. And definitely, we need to set up a highly available architecture for OpenStack. And we do need to scale the Cloud Foundry components itself. So as we saw in the architecture, NATs or the messaging get bus, it's actually communicating through all the components of Cloud Foundry. So we do need to ensure that the timeout policies in NATs are high enough so that as these communications are going on, Cloud Foundry is not breaking down. And then we need to use specialized networks so that your application traffic is isolated from the Cloud Foundry management traffic. In case of OpenStack, we actually use the Neutron private network for Cloud Foundry management and a floating IP or a floating public network for the router component. And then we do need to deploy Cloud Foundry, especially in the highly available architecture. So with this, I do want to summarize why Cloud Foundry and OpenStack are a great fit. First of all, they are both open source PaaS and IaaS solutions. So that means no vendor lock-ins. They both have a strong and growing community of contributors and sponsors, and a lot of tools and technologies are being written which can be leveraged to actually automate this whole life cycle of Cloud Foundry and OpenStack. And all the integration requirements which Cloud Foundry has from an infrastructure as a service, OpenStack totally meets it. So bottom line, they are a great fit. Go get them integrated, automate this, and deploy lots and lots of applications. Thanks.